All right, so just a quick recap. Remember, we are doing calculus, and we said that the two main branches are integral and differential. And so we said that we start with differential because integral actually is formed from the basis of this change, okay? So now it's a reversal of the change that we had. So now we are looking at differential, and we said that there's no better place to start than limits. Once we understand limits, we can use those to say that now we can obtain derivatives which represent change between variables or between a variable and time. Okay, so this is a limit definition to give you a derivative. Okay, and so we went on and said after we get these, these derivatives, you could get them through the limit definition, and you could also get them through the rules. Now, what were the rules? The rules are just a split of this one, the limit definition, because the limit definition gets almost any derivative that you want. The problem is that it's very cumbersome and it's tedious, okay? But the rules are simplification of that. But the problem is that they are limited to type of function. So if you have xn, you can only do it with the power rule. If you have x plus 1n, you can only do it with the chain rule. If you have x plus 1 over x plus 2, you can only do it with the quotient rule. If you have x plus 1, x plus 2, you can do it with, if you don't expand this, you can probably only do it with the product rule, something like that. So we did all the rules, okay? So we did about 4 rules that I feel are important. But then that does not cater now for other types of functions. Remember, the basis is functions. So we don't cater for some type of functions. Which functions are these? We can look at the trig, we can look at the exponential, we can look at the trig, exponential, and logarithms. Okay. So if we get these 4 plus these, then we would have simplified how to get the derivatives using these other methods. Okay, because this one is quite tedious, but it gets almost any derivative that you'd be looking for. Okay, so that's the simplest explanation of why now we need to look at the trig, the exponential, and the logarithms. So we'll start with the derivatives of trig functions in this one. Okay, so what are these? We are saying that the derivative, so letter d can be used to mean derivative. This is the same thing we said was dy over dx or dfx over dx, things like that. So this is just to save some space. We've used the capital letter D. Right, so the one for sine is cos x. The one for cos x is negative sine x. The one for tan is sec squared x. The one for cotangent is cos x squared x. And then the one for sec is sec x tan x. The one for this is that. So these, you don't have to derive them again using the limit definition, okay? But you have to know them just the way they are, okay? You can't come and say now maybe the sine, the derivative of sine is going to be tan. No, it's always going to be cos x. The one for cos x is going to be negative sine x. So these are preset. These are preset. You can't change them. Okay. So now, how do we know these, or how do we remember them easily? So this is what this is trying to do. So I find that the easiest way to know them, there are other diagrammatic views that you can try to understand. It helps you, but also you can have a mental note that can support that. The mental note is this. These can be classified into 3 types of relationships. So the first is to classify the relationships. So these are the permanent relationships. If I see sine, I must know that the derivative is going to be cosine. If I see tangent, I know that the derivative is going to be sec. If I see quot, I know the derivative is going to be cosec. If I see cosec, I know that the derivative is going to have. So these are permanent relationships. You can't get a derivative of sine and then you have a combination of other things. It's going to be just this and that. The derivative of tan is just going to contain these same 2 terms only, and like that. So this is where we need to first spend time and master. Okay, so these have to be mastered, these relationships. Okay, the second thing to note is that these can also be split into those that contain 2 terms and those that contain 3 terms. So the ones that contain 2 terms are these ones. So these ones are going to contain two terms. These ones. Okay, so these contain two terms. What do I mean? It's going to have sine and then it's going to have cosine only. It will not have another term here. So if I'm looking at the derivative of sine, I need to expect that it's only got one, which is cosine. If I do cosine, it's only going to have one, which is sine. The next thing to look at is that the rest now, because we're looking at 6 basic functions, they have 3 terms. Now these terms are set out a bit differently. Okay, so this is only complication here, but you should know that they have 3 terms. That we said the relationship only contains tan and sec. Okay, so let's find our terms. So if I come here and I look at tan x, okay, so the functions of tan and its inverse, they contain 2 terms, 3 terms as well. So there's 1 and 2 here. Okay, so you must think of it like this. Okay, because in most terms you actually need to even separate them like that sometimes. So you must see them like this. So this is 1, 2, 3. So you can see that there are 3 terms. And we look at the relationship, we said that it must only contain these functions, tan and sec. Okay, so if we go to cotangent as well, cotangent will have 2 terms, but then they'll have these 2 terms, 3 terms here. 1, 2, 3, 3 here. 2 plus 1, okay? Then we'll go to these ones. They'll also have 3 terms. Now we're looking at the reverse relationships, okay, for these ones. They also have 3 terms, but they are actually arranged differently. So you'll see that sec will contain only sec and tan, like we said, sec and tan, nothing else. Must never confuse you, like whether this is sine, whether this is sine or sec, or it will always just be from that relationship that you formed here. That's why I said these, you must remember them. So from that relationships, then you can actually just figure out how they are set out. So for example, here, I know that the relationship between sec and it will be sec and tan, just those. Then I know it will not be square like that. So it means that I'll have 2 different terms here. Same here, to have 2 different terms. The only ones that have got square are the derivatives of tangent and its inverse. Okay, and we know, once we know the relationships here, we can now figure out how to put them together. So this is what you have here, and this is what I was trying to explain here. The ones with the 2 terms are these ones. The ones with the 3 terms are these 4 here: tan, cot, sec, and cosec. But then the only thing that we need to remember is that tan and cotangent have got a square in them, which is that. The last thing that is not very difficult to remember is that you also have negative sign. So negative is for cosine, cotangent, and cosec. So all the co have got a negative in them. So you can see here, this is how I actually want you to remember. Cosec will give you a negative. This one doesn't have co at the beginning. This one will have co, so expect a negative. Okay, this one is cosine. It will have co. It's also going to give you a negative derivative. So this is the final point, which is sines. Actually, sines is that. So sines, we are going to have to remember that these, as long as it's got co, the derivative of anything that's got co is going to be negative. Okay, that's the other thing that we need to remember. So if I'm getting cosine, I'll get sine, I'll get negative. If I'm getting cotangent, I'll get negative. If I get cosec, I'll get negative. Just that. If you remember these 3 important, the relationships, the number of terms, and the sign, then you're good to go. It's not something that you can easily forget. All right, all the best.